Hi everyone, welcome to Integral Calculus. Today we explore lesson 6.3 volume by cylindrical shells. Let's take a look at an example. Let's say that we have a region bounded by this graph right here, y equal fx, and this is the bounded region. And we're going to rotate this bounded region about the y-axis. So when we do the rotation, we're going to get this. Well, usually we would try out a sample stripe like this. And when we rotate this sample stripe, we're going to get a washer. How do we figure out the volume of this washer? Sample washer. Volume is, of course, base area multiplied to thickness. Yeah. And if you look at the base area, it's gonna be the area of the bigger circle minus the area of the smaller circle. That's pi r square minus pi r square. The thickness is dy. So that means we got to write everything in terms of y. And this can be a problem because if you look at this function, sometimes we cannot fully express the radius in terms of y. Draw this stripe instead, and when we rotate it about the y-axis, we're gonna get a shell or a ring. Sample ring. A lot of people say sample shell. The volume of the sample shell is, as you can see, we can cut it out. Let's just cut it out. Cut out. And it would look like this. So what we have is the circumference of the circle. It's 2 pi r. And then we have the height y. And then we also have a little thickness right here. The x volume is circumference. Multiply to height. Multiply to thickness. Yay. Once we have a volume of a sample shell, we use the same trick, right? We add them up and take the limit as n go to infinity. So the limit of the Riemann sum is the integral. And then we integrate that based on this problem. It would be from this point to this point. So I'll say from A to B here. Of a sample volume. Yeah, and the sample volume is circumference multiplied to height multiplied to thickness. Yeah. 2 pi, the radius is r, the height is y, and the thickness is dx. Well, we know y is fx, right? Because that is the height. And then the radius, as you can see, this is the radius of the ring right here. That is just x. 2 pi x times fx times dx. Example, find the volume of the solid by rotating the region bounded by y equal to x squared minus x to the 3 and y equal to 0 about the y-axis. We can sketch out the region x, y. So this is y equal to 2x squared minus x to the 3. Y equal to 0, just the x-axis. And so this is the bounded region right here. When we rotate this about the y-axis, it would be wise to use the shell method, because if we draw this as a washer, then we cannot solve for x. It's not possible. So we can rotate a sample stripe, a vertical sample stripe, and that would get us a shell. Sample. Shell. It has volume of circumference multiply to height multiply to thickness. Circumference has 2 pi times the radius. The height is y. The thickness is dx. We're going to integrate with respect to x. So the integrand must be in terms of x. If you're going to look closely at the radius, this is the radius right here. It's x. No. 2 pi x. The height is y. We know y is 2x squared minus x to the 3. Dx. Ah, amazing, huh? 2 pi 2x to the 3 minus x to the 4th dx. Simplify this. And ta-da! Here comes the volume. It's going to be the integral from this point to this point. So that is just the intersection between the curve and the x-axis of y equal to 0. Let's take a look at intersection. Point. 2x squared minus x to the 3 equal to 0. Fact that x squared, we have 2 minus x equal to 0. And we have x equal to 0, x equal 2. So one point 0, the other point 2. And now we can compute the volume. Volume is integral from 0 to 2 pi 2x to the 3 minus x to the 4th dx. Yay, so there's the 2 pi 2 over 4 is 1 over 2 x to the 4th minus x 5 over 5. Integrate from 0 to 2. We have 2 pi, plug in 2, then we have 8 minus 32 over 5. Plug in 0, we just have 0. And work out the arithmetic, then we have 16 over 5 pi. Awesome. Let's do another example. Find the volume of the solid by rotating the region bounded by y equal x minus x squared and y equal to 0 about the line x equal 2. First, the intersection point here, set them equal x minus x squared equal to 0. So we have x1 minus x equal to 0. So x equal to 0, x equal 1. Meaning that we're going to have an upside down parabola. And it's going to intersect at 0 and 1. We rotate about the line x equal 2. So this is the line x equal 2 right here. Then we're going to get something like this. And there's the reflection on the other side. And we don't want to use the washer method because it is not possible to solve for x. So we have to use a shell. And that is the sample shell. Take a vertical stripe and rotate about the line x equal 2. Then what we have is a sample shell. Volume is circumference. Multiply to height. Multiply to thickness. Okay, circumference is 2 pi r. Height is y. Thickness is dx. Now, same thing here. We integrate with respect to x. So we have to write everything in terms of x. The height is y, and then we know y is x minus x squared. The radius, this would be the radius right here. As you can see, it is a distance of 2 minus x, because this distance right here is x. So that distance is 2 minus x. 2 pi 2 minus x. Pretty cool, huh? Boil it out, and we have a 2 pi multiplied to 2x minus 3x squared plus x to the 3. Yay. So now we can set up the volume as the integral from 0 to 1. of a sample volume. 2 pi r y dx, which is 2 pi times 2x minus 3x squared plus x to the 3 dx, and ta-da! 2 pi, the antiderivative is x squared minus x to the 3 plus 1/4 x to the 4th. Evaluate from 0 to 1. 2 pi, plug in 1, we have a 1 minus 1 plus 1/4. Plug in 0, we have 0. Work out the arithmetic, and we have pi over 2. Super cool. Thank you for watching. I hope you find the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.